Imagine you want to add 8 and 2 in a calculator. First, you need to press 8 plus 2 and equal to get your result. When you press any key, it makes an electrical contact with the keyboard sensor underneath it, which sends a signal to the microprocessor. As you strike the 8 button, the microprocessor displays it on your screen and stores the digit in a short-term memory. But as soon as you push the plus key, the microprocessor performs two tasks. The first one is encoding the digits you've entered in its binary form. In this case, 8 becomes 1000, so it can be transmitted by electricity. Now, the encoded terms get stored in the random access memory. But how? If we zoomed in the RAM, we will find a lot of electrical components called capacitors, which have two states: charged and discharged. Since 1000 is a 4-digit information, the microprocessor reserves 4 capacitors for it. The second task, though, is setting a proper electrical circuit for the selected operation. Since you have selected addition, the microprocessor makes a parallel circuit with 2 logic gates, which is named a half adder. But keep in mind, the more terms, functions, and operations you type, the more complex circuits are set. Now you press 2 and it gets displayed on your screen, but that moment when you press equal, the microprocessor encodes the last term 2 into 10, and it occupies 2 capacitors in the RAM. Then the 2 digits are sent from the RAM to the selected circuit. A half adder is a circuit that performs very simple binary addition, and logic gates, though, are electrical components. There exists 4 gates. AND gate: if both inputs are 1, then the output will be 1, else the output is 0. OR gate: if one of the inputs is 1, the output will be 1, else it's 0. Exclusive OR gate: if the inputs are 1 and 0, then the output is 1, else it's 0. NOT gate: this logic gates reverse any input. Anyways, we can simulate what's happening inside the circuit using a truth table. The inputs are A and B, which are the digits, and outputs are A plus B and the carry. If you quite don't understand why there are 2 outputs, then here, imagine if A is 9 and B is 5, their sum is 4 and the carry is 1. If we combine them, it will be 14. In binary, since we can't have numbers above 1, the carry starts if the sum is above 1. So let's get back to what we were at and see the results. This is 2, this is 8, and this is 10.
If there is a carry, the microprocessor uses a full adder.
And final, the result of your addition is 10 or 1010 that gets stored in the RAM and then decoded by the microprocessor and finally displayed on your screen.
Yay!